Assalamu alaikum dear students. I am your teacher of the class 7 General Science. Today I am going to continue the previous chapter, which is sound waves. Now today we are going to start the new topic, which is compression, vibration and the sounds. So in this vibration here is occurring the compressions. So what is the compression? The part of the sound wave where the air pressure is greater as the air molecules are bunched up are called the compressions. That part of the sound waves where the air pressure or the air molecules are gathered up is called the compression, and where the air pressure is greater. You can see in that picture the dark pink color or the compression. You can see in that picture the air molecules are bunched up at one place. So where the air molecules are bunched up at one place, this is called the compression. Clear? This is called the compression. Now coming towards the rarefaction, which is opposite to the compression. So what is the rarefactions? The part of the sound wave where the pressure is less as the air molecules are spread out are called the rarefactions. So rarefaction is opposite to the compression. So that part of the sound waves where the air molecules are spread out, this is called the rarefaction. You can see in that picture the rarefaction as well the compression. Compression means where the air molecules are bunched up at one place. This is called the compression. While the rarefaction where the molecules are spread out, this is called the rarefaction. While in case of the compression, the pressure is greater. While in case of the rarefaction, the pressure is less. Clear? Now coming towards the sound waves, the compression and the rarefaction of a medium like air. You can see in that the tuning fork. The tuning fork produces some vibration. Clear? So in this way they produce the compression and the rarefaction because we need to hear the sound. So in this way the sound waves are moving, right, and they produce the compression and the rarefaction. In the compression, all the air molecules are gathered up or the bunch up at one place, while in case of the rarefaction they spread out. Now coming toward the handbell vibration. Handbell vibration. A handbell vibrates when you shake it. When you shake it, the handbell start vibration. The vibrating bell push to and fro. To and fro means forward direction and the backward. Forward movement and the backward movement on the air molecules around it, making the air pressure rise and fall. Simply when you shake the bell, it start moving, it start vibration in the upward direction and in the backward direction and in the forward direction from their main point. Clear? So in this way the air pressure are rise and fall, greater and less, while because the bell are start moving in the backward direction and in the forward direction. So in this way the pressure sometimes increases and sometimes decreases. So the rise and the fall of the pressures will occur. These pressure changes are passed on by the air molecules around it. Clear? The air molecules pass these changes of pressure. When the pressures change, the air molecules carry these pressure changes and pass it. Clear? I repeat again. These pressure changes are passed on by the air molecules around it. A sound wave travels away from the bell. Clear? The sound waves travels through the air molecules. Without the air molecule, we are not able to hear the sound. You can see in that picture the bell. So the bell are moving in the backward and in the forward direction. Waves of the energy. Now coming towards the waves of the energy. Here is the waves of energy divided into the two types, the transverse waves. The one of them is the transverse waves. So what is the transverse waves? Clear, you must know about that. The transverse waves occur in the water. There are the differences between the way in which the water waves and the sound waves travel. There is a big difference between the water waves and the sound waves. Water waves are the transverse waves. When a stone is thrown into the water, it is not the water which is moving out from the splash. Clear? The water is not moving out. The water molecules are simply bubbling up and down at the right angle to the direction of the waves. Clear? The water waves produce the waves. Clear? And these waves are moving at the right angle to the directions of the waves. You can see in that picture, this is the transverse waves. Clear? The transverse waves produce like this, right? So the transverse waves produce it is in the two direction. The crest, the upward movement of the water, it is known as the crest, while the downward, which is below the dotted line, this is the downward. The downward movement, it is called the trough. Clear? And the distance between the two crest is known as wavelength. So the water moves like in that direction, like in the crest and like in the trough, at the right angle to the wave, at the right angle to the directions of the waves. So the water moves like the transverse waves, in which is the crest and the trough is occurring. The upward wave is known as crest, while the downward wave is known as trough, and the distance between the two crests is known as wavelength. Now coming towards the longitudinal wave, this is the second type of a wave which is occurring in the sound. Clear? The transverse waves occurring in the water, while the longitudinal wave occur in the sound. When a sound wave travels through the air molecules vibrate. When the sound wave travels through the air molecules start vibration in the same direction as the sound wave is traveling. Clear? Where the sound wave is traveling, the air molecule traveling in the same direction. Both the direction are the same. This kind of wave is known as longitudinal wave. When a sound wave travels through the air molecules start the vibration in the same direction as the sound wave is traveling. Both the direction is same. The direction of the air molecule and the direction of the sound wave are the same. In this way, the longitudinal waves are traveling. You can see in that picture, this is the longitudinal waves, right, in which the compression and the rarefaction is occurring. Compression in which all the molecules are bunched up at one place, while the rarefaction in which the air molecules are moved in all direction. Clear? In this way we can hear the sound and the sound reach to the person ear. Example of the longitudinal wave. You cannot see a sound wave, but a slightly spring shows how the longitudinal wave travel. Example is that if you hold a spring between your hands and pull one end of the spring in and out, so what will happen? You can send a longitudinal wave along the spring. Clear? The coils of the spring. In the sound wave, the coils are occurring. So, the coils of the spring move close together, then after some time, then further apart. They move further apart from each other as the waves transfer energy along the spring. Clear? So, it means that there is a compression and a rarefaction in which the molecules are gathered up or the bunched up as the molecules are transferred to another place, and then we hear the sound. You can see in that picture, in one of them there is a longitudinal wave. In the left side you can see the longitudinal wave, as well in the right side you can see the transfer waves. So in the longitudinal waves, the waves are in the form of the coils, in the form of the spring. You have noticed the spring in your pen. Clear? As like that, the longitudinal waves are in the form of the spring, in which the compression and the rarefaction is occurring. While in case of the transfer waves, there is a two type of the waves occur, which is called the crest and the trough. And the distance between the two crests is called the wavelength. So, the transfer waves always occur in the water, while longitudinal wave occur in the sound. Clear? So, you know very well about it that the speed of the sound in the vacuum. So, what does it mean by the vacuum? Vacuum means when there is no air molecules, which is the space free, which is the free from the molecule. So you have seen that sounds cannot travel through the vacuum. Why it does not travel? What is the reason behind it? Because there is no air molecule. Air molecule carry the sound, carry the vibrations. So this way we hear the sound. When in the world there is no air molecule, we are not able to hear the sound of each other, because the sound vibrations need atoms or molecules to carry them from one place to another. Speed of the sound. Sound can travel through the gases. Most of the sounds you hear travel to your ears through the air. In the air, the speed of the sound is about 330 meters per second. It is accurate, yet you must have to memorize it. Thank you, students.